Hey guys, Mick from Specto Technology here. Today I'm going to show you how to calibrate a VOC module in the AQS1 monitor. So what we're going to do is take you through how to connect the gas cylinders up to the monitor, and then take you through the software and how you actually update the calibration curve on Aeroqual Cloud. So the first thing we're going to do is just show you the hardware that we're using here. So this is in your service kit. This is a flow regulator at 0.1 litres per minute, 100 mils per minute. So you have this, you have some tubing. This is Teflon tubing. It doesn't absorb any contaminants, so it's clean. And then you have the T-piece here at the end. So really all we're doing from the physical side of this calibration is just connecting the T-piece up to the gas sample train. You just do that finger tight. The T-piece has an opening, so that's how we want that, so that there's excess gas flowing into the monitor. We don't want to pressurize the gas module, so we have excess gas flow for the module. We then take the flow regulator. Now this just connects to the gas cylinders that we've provided, or you can purchase. Just screws in on the top. Just screw it in all the way. It doesn't have to be too tight. When you screw it in, you'll see the needle. You'll see the needle on the regulator, and that'll show that there's pressure in the cylinder and that you've actually got gas in there. If that needle's down to 0, then your cylinder is empty. To open the regulator, it's just a knob on the side. You just need to crack that. You can hear it coming out. You then just want to attach that to your tubing. Make sure that's on securely so you haven't got any leaks. And there you are now providing gas to the air quality monitor. So there's two types of gases that we're going to provide for the calibration. There's zero air, and there is isobutylene, which is a VOC. So we're going to firstly calibrate at 0 and then calibrate with our VOC concentration. So that is all there is to do from this side. Obviously when you're swapping cylinders, you're switching that off again. You're just unscrewing the regulator and you're just screwing the regulator back on to this cylinder. Just want to open that up again, and then now we're actually feeding it the isobutylene. So that's all there is to it. When you're finished, just want to take the T-piece off, and you're back to monitoring. So let's go have a look at the software and show you how to make any changes there. Okay, so today we are going to show you how to calibrate the AQS module. I've shown you how to connect the gas cylinders. So now we're going to look at the software. So if you just take a look at the Aeroqual Cloud, here I am with the unit that we're calibrating, 1455. So if you just want to press Calibration and Service, that's the section that you want to be in. When you get to Calibration Service, you see this screen. Now, the first thing that you want to do when you calibrate is go to Manual Entry and press Start Manual Service. Okay, so if we're in the starting manual service, we're now going into service mode. It's very important to be in service mode because none of the data then gets recorded when you are calibrating. So you can get some odd numbers when you're calibrating. So we don't want that data to be included in the data set. So here it says service mode pending. At some point that will say service mode connect or in service mode. So that's just loading. We're on online here. So okay, I'm going to go to the next step. So what you're seeing here in this box here is the current reading for the system. There is different modules here. You can have your particles, your weather station or battery voltage, and your gas. We want to be on gas. So obviously we're doing the VOC module. That's a gas. The VOC reading at the moment is 0.01. I have the zero air connected to this monitor, so if you can just connect and clicks, you can just click Start Calibration Run, then we can get going here. So what we want to do is start a new calibration run by adding this. If you're renting from us, this will just be called VOC Calibration Run, and you won't have to do this part. So just to show you how you start a new run, this is VOC Calibration Run. The first action we're going to do is to run some zero air through the monitor. We want to add another action, which is to run some isobutylene through the monitor. So we'll select span port 1, choose VOCs. We're just going to be using a cylinder concentration today of 10 ppm. So you just want to make both of these sections 10 ppm. So this is our span concentration. So we just highlight that at 10 ppm. If you have if your cylinder has 1 ppm, then you want these to be 1, or if it's more, whatever your concentration of your cylinder is, you need to change it here. So that's changed there. And then finally, we just added a third calibration point for a full calibration, which is another 0. So, right, so what we're going to be doing, we're going to be giving zero air to the module. Then we're going to be giving our VOC gas isobutylene at the concentration of 10 ppm into our module, and then we're going to be giving zero air again. So this is our calibration run for today. So I'll just select that. When you select that, it asks you, it shows you what you're doing, and it allows you to press start. So it gives you some guidelines that this is the external calibration run is a guide. You need to manually control the zero and span, which is what we're going to be doing. So, okay, so you're in here. Now you can see we've got external calibration run in progress up the top here. So that's, you now know that you're in service mode. And here's our calibration. All right, so it says this arrow here says what we're in, what section we're in. We're in 0. So at the moment, we've got 10 minutes of being in this section, the zero air that we are feeding this monitor. So you have a look at this box. So what is this box here? This is the last 10 readings, and this box up here is just showing you a graphical version of that. So right, so what you can see here, I've been feeding it zero air for a while, and it's very constantly giving me a reading of 0.01. Okay, so that is within the tolerance for this monitor and this calibration. So you wouldn't really need to make any changes here. So the two things that you want to see when you're calibrating is that you get a stable number. So it's around the same number, plus or minus, 0.1 ppm when you're working with the VOC H module at 0 here. So we're well within 0.1 ppm. Our standard deviation, this is actually just saying how different are the last 10 numbers here. So if you're doing a full calibration, you should wait for 10 minutes, and that standard deviation should be very low, so around 0.02 or thereabouts. So you might not have time or have a requirement to do this really extended calibration for 10 minutes. So if you're getting a stable reading after 3 or 4 minutes here, then you might elect to continue on to the next stage. So with this, I'd be happy if I'm seeing the exact same reading for say 3 or 4 minutes that that the module is stable. If I was doing this in a laboratory, or I was doing it for the first time, I really would want to do the full 10 minutes just to ensure that the monitor is stable. But in the field with some, you don't always might not always have time to do that. So 3 or 4 minutes of a stable number would generally be, you'd be fairly sure that you have a valid reading. So the next thing to do would be to skip to the next section because you're happy with this number. Now, if you weren't happy with this number, if this was saying 1 ppm, well, we wouldn't be very happy that our zero air is saying 1 ppm. So in that case, you just simply hit this recommend button, and the software just recommends a new offset for you, and then you just click the apply button. So if you do that, I'll just do it anyway, even though my number's quite fine. It's well within the 0.1 that I'm plus or minus 0.1 that I'd be concerned about. But you just press the apply button. Okay, so what that's done is that's just offset and made the instrument believe that it's reading 0. So if we just waited another minute, this would actually just change to 0.00 because I've just offset this reading. And so that's called changing your zero calibration. So you don't need to do that unless you have a number that's greater than plus or minus 1 ppm. So typically, it's not so common that you have to do this. The sensor is very stable and reads the zero reading very well. So, okay, guys. So that's how you do a zero calibration. You should also do this at the end of after you have used the VOC cylinder. I recommend putting the zero cylinder on again, and just to check that you are getting that zero reading. So I'll do it for 3 or 4 more minutes at least. I would do 10 if you're going to be abiding by the manufacturer's recommendations, 10 full minutes. And as you can see here, it's now changed to 0. So I made that small offset of 0.01, and now we're at we're reading 0. So that's about it for a zero calibration. And the next part is a little more interesting because we're going to give the module some gas at 10 ppm, and so we're going to see what happens when we do that. I'm going to skip to this section. So if I just skip here, I can stay in this section. If I'm doing something, I'm busy, or I want to leave this running for a while, I can just change the number of minutes here as I'm going along. So I just leave it for 10 minutes usually. So now we're actually in the VOC section. Now we haven't changed the cylinder on the bottle, on the monitor, so we can't just expect that we're going to get readings here, because we actually have to physically go and change the bottle. So I've shown you how to do that in the previous section. So let's just fast forward in time and imagine that I have changed the bottle over. I've attached the VOC at 10 ppm to the monitor, and we've been waiting for a number of minutes. So let's have a look, and we're just going to fast forward to that now. Okay, so now we're going to look at the span calibration. So I'm just going to start this run again. We've done the zero. I've actually got a cylinder of 20 ppm VOCs of isobutylene. So we're going to use this cylinder with 20 ppm. So I changed that. You can edit here. Instead of using 10 ppm, we're using 20. So you can edit each of these points here. So now we'll start the calibration run again. Okay, so we have completed our zero calibration, so we want to skip that section. So it's very important that this arrow, when you're doing the span calibration, is on the VOCs, and it's really important that this number here is the same as the concentration in your cylinder. So I've got 20 ppm in my cylinder. You're going to have 20 ppm here. If you had 1 ppm in your cylinder, you've got to have 1 here, because that's the way that the software will know how to adjust your calibration. So if we have a look here at the last 10 numbers, so I've been feeding isobutylene gas to the monitor for at least the last 10 minutes. And you can see these numbers are quite stable. So we've got 19.83. This is our last reading. Okay, so we have a very low standard deviation, and we're actually within our tolerance here. So the tolerance for a span calibration is 5% of the span concentration. So 5% of 20 ppm in this case. So 5% of 20 ppm is 1 ppm. So for this calibration, as long as we are between 19 and 21, so 20 plus or minus 1 ppm, 19 to 21 ppm, we don't have to make any changes at all. We've got a very stable reading. As I said, for manufacturers, recommends doing 10 minutes worth of data. If you select to do 3 or 4 and see that it's stable, I mean that's your choice. Be reasonably confident that would give you some valid data. So we see here that really there's nothing that we have to do. So if this number was outside of the range 19 to 21, then we would want to change the gain. So to do that, we would hit recommend, and then we would hit apply. And what that would then do would tell the monitor that it should be reading 20 ppm instead of whatever it's reading. So I can click apply there, and it will say, do you really want to apply this gain? Yes, I do. And so that is going to probably just bring that number up to exactly 20. But because I'm within that plus or minus 1 range, there's no need to change the gain. Just like with the offset, if you're within plus or minus 1, there's no need to change the offset. You're better off leaving it as it is. So, okay, stable reading, low standard deviation. We are satisfied that we've calibrated this at our span concentration of 20 ppm. So I would then just skip, and the next and final step, I would then swap the cylinders over again, and just ensure that I am reading at 0. So we've started with 0. We look at our span, and then the manufacturer recommends that you then check the 0 again at the end. So that's how you do a full calibration. If you were just doing a quick calibration check, I'd recommend just you don't even have to go in this area. Just put on your gas cylinder, and then just have a look at your readings in your manage data section. So once you've applied that gas, wait 2 or 3 minutes for it to change. It's going to take that time, as I said, because it's pulling at a very low flow rate. So if you were just doing that, and then you were looking at your last minute data, you could just look at your data here and satisfy yourself that you were reading at around your span. So you could do a quick calibration check of the system with your span gas cylinder, or you can go through the full calibration that I just showed you. You doing the 0 gas and the span gas. So remember, if you're finishing your calibration, to stop the calibration run and also stop being in service mode. So you don't want to be in service mode anymore, because you've done your calibration and you want the data to be valid again and part of your data set. So we've changed that. You see it's slightly, I did do that small adjustment on the gain, so that changed to 20. So there you go. That's how you calibrate this module. I just want to show you a couple of tables at the end. This is just for reference. These are available on Aeroqual support if you look at calibration, or on the online manual. This is where you can see what the manufacturer recommends. So I was using these numbers. For a 0 calibration, you want to be within plus or minus 0.1 ppm, and you want your standard deviation to be 0.02. So very stable readings. And then likewise for your span calibration, we were using the VOC module here, span of plus or minus 5%. We're at 20 ppm, so that number was plus or minus 1 ppm. And then we also had the standard deviation of 2% of span, so that's what you have, your tolerance there. So 2% is actually 0.4. So you have quite a wide range there. I think it should be
it's usually even more stable than that. You don't see too much variation of those numbers in your 10 minutes of data. So okay, there you go. So thank you very much for listening, and good luck.